Hello, this is Sam with the Eliminated Pathways Agency. I'm back here for another lecture in our 2026 AI lecture series here. This one is about recursive AI. And before I start, if you could like and subscribe, I'd appreciate it. But I also need to let you know that this lecture that was written about 6 weeks ago is already sort of out of date. Not in a bad way. Matter of fact, I'm still going to continue with the lecture, and most of the information is still very relevant today. What's happened though is recursive AI has become a reality. Thanks to the Arise Foundation out of Princeton and Google's DeepMind, playing and using AI a game called Pokemon, they have actually been able to create a recursive AI environment. This is huge. There's a couple things to note, and I want to note them before I get started. First off, it is open sourced. That means that you and I, if we have the capability to run and use GitHub, as long as you know how to use APIs and stuff like that correctly, you could actually use this right now. It's called Continual Harness. You can look it up on Google, look it up on YouTube. I'll try to remember to leave a link in the doogly-doo below, so that way you can actually see and learn for yourself firsthand from the paper that was just released. I want to say May 11th of this year. Give you an idea, this is May 28th when I'm recording this, so just a couple weeks ago. Now, because it's open source, that means anyone can get it. That means the bad people too. Now, I don't think for a minute that the guardrails and safeguards that are already in place is going to be overturned or anything like that by these people, but I'm sure that there will be things that we have not thought of that will happen. That's just the way technology goes. However, there's a lot of good that's going to come out of this, I believe. Because it's open source, any researcher can use it. That means doctors who are working with medicine who actually know medicine. And just a quick intro here, if you didn't already know this or haven't heard this from me before in one of my other talks, you have to bring context to AI. If you don't bring context, AI is not going to really help you all that much. It might give you an idea, but 9 out of 10 times that idea is not going to be useful, or it'll be wrong just enough. It becomes that buddy who kind of knows everything, but as soon as they talk about a topic you realize they're kind of talking like a pseudoscience version of what's really going on. That's what AI without context is like. So I'm not worried about the bad people so much, but I'm very hopeful of all the good people, the people with context, that's going to be able to solve some of our problems that we have. And I think that's where our future is. Continual Harness. So most people who have been working in this field of recursive AI have been using a game called Pokemon. It's an older game. It's considered a very good strategy game for all intents and purposes. I personally have never played it, but that's my understanding of it. So having an AI be able to beat the game at increasingly difficult levels is a measure of how good the AI actually is. And at this point, Continual Harness is an agent that sits on top of a frontier model, such as OpenAI's ChatGPT, or even better, in my opinion for this case, Google Gemini. And the reason why I say that is Google DeepMind is kind of the brain behind all of this that we're talking about right now. So working with its own ecosystem, it has better access to tools and stuff like that that can be used. Another thing I want to point out is, even though I'm going to be talking about the speed of how recursive AI could increase its intelligence and develop, that's not the case yet. The fact that it took thousands of hours in order for the AI to actually improve itself, it's still quote unquote slow. It's just faster than us, plain and simple. The other thing, and I will talk about this briefly in my lecture coming up, is if you give it the wrong information, or if it has the wrong information, it will follow that misinformation as if it was real. And this will magnify, or could magnify, the mistakes, the errors. Here's the good news. Once it figures out that that's not working, instead of holding on to that concept, much like a human would, if we've learned something and we believe it's true, right? It takes everything to change our mind. AI, once it figures out that it's wrong, simply does it, changes. And that's the big takeaway from this. Yes, with bad information, misinformation, it can be bad. I won't lie about that. I won't try to cover that up or make it softer. It wouldn't do any good. But again, I want to concentrate on the good news is once it knows it's wrong, it can fix itself. The last thing I'll keep in note before I start my lecture here is this is still the very beginning of recursive AI, and it's still very much a hands-on. There's still people involved in each step of the process and all that. So we're not going to have a runaway situation or anything like that. That's great for the movies and great for stories. In real life, that's just not how it works. These are being developed in a enclosed environment, and most of the things that people can think of have already been placed guardrails and safe rails around it. So with that in mind, if you want to use recursive AI today and you have the computing power to do so, I think you need at least 24 megabytes of VRAM in order to run it. If you've got that on your graphics card and stuff like that, you should be no problem. So go to GitHub, make sure you read the documents and all that stuff. I'll try to include the GitHub link down below as well. So with all that in mind, on with my lecture on recursive AI. And again, don't forget to like and subscribe. I appreciate you. So what if the most important breakthrough in artificial intelligence is not a machine that thinks like a human, like we discussed in DIS systems, but a machine that improves itself faster than any human can? What if the next revolution is not intelligence alone, but intelligence that redesigns intelligence? This is the coming age of recursive AI that we're now in. Artificial intelligence has already changed the modern world. It can generate language, analyze data, create images, write software, optimize supply chains, and assist in scientific discovery. Each year, these systems become more capable, more efficient, and more integrated into daily life. Yet all of these achievements may represent only the beginning of something far larger. Because today, most AI systems still depend on humans for their advancement. Human engineers design architectures. Human researchers tune models. Human teams decide what data to use, what objectives to optimize, what safeguards to implement, and what improvements to pursue next. AI may assist in parts of this process, but humanity still occupies the central role in directing progress. Recursive AI would change that. Recursive AI refers to systems that can meaningfully improve their own capabilities, then use those improvements to generate even greater improvements in future cycles. In simple terms, intelligence becomes the engineer of intelligence and keeps the cycle going to get even better and better. This idea has fascinated scientists, philosophers, and futurists for decades because it introduced a possibility unlike ordinary technological growth. Most progress is linear or incremental. Recursive progress can become exponential. Imagine a machine capable of redesigning its own code, refining its reasoning systems, accelerating its learning methods, improving its hardware efficiency, and generating better successors. Each upgraded version becomes more capable at creating the next version of itself, and so the loop continues. Improvement begins producing improvement. That dynamic can transform AI development from a slow staircase into a vertical climb. To understand why this matters, consider how human progress normally works. Civilization advances because knowledge accumulates across generations. One scientist builds on the discoveries of another. One engineer improves previous inventions made by other engineers. But humans are limited by time, attention, biological constraints, and institutional friction. Recursive AI would operate differently. It would not need sleep. It could duplicate itself across servers. It could run thousands of parallel experiments at the same time. It could test hypotheses continuously, and it could remember every iteration. It could integrate discoveries instantly across copies of itself. Where human progress is sequential and social, recursive machine progress could become simultaneously and continuous. This does not mean an overnight explosion into omnipotence, as some dramatic narratives suggest. Real systems face limits: compute power, energy costs, data quality, physical hardware constraints, and diminishing returns. But even with limits, the shift from human-paced improvement to machine-assisted self-improvement could be historically unprecedented. The first major impact would probably be in scientific acceleration. Recursive AI systems could help design better materials, discover medicines, optimize energy systems, simulate climate interventions, and generate mathematical insights at speeds no research institution can currently match. Problems that require decades of iteration might be compressed into years or even months. The second impact would be in economic transformation. Companies that deploy self-improving AI systems could dramatically outpace competitors. Productivity gains might compound rapidly. Entire industries from software and finance to logistics and manufacturing could be reorganized around systems that continuously optimize themselves. The third impact would be strategic power. Nations that lead in recursive AI may gain advantages in cybersecurity, defense planning, intelligence analysis, infrastructure management, and technological dominance. You see this playing out between US and China right now. Because of this, recursive AI is not only a scientific issue, it is a geopolitical one. And this is where the stakes rise. If intelligence can improve itself, then whoever controls that process may control the pace of future civilization. Yet the greatest challenge is not speed. It is alignment. A recursive system optimized toward the wrong goals could be more effective at pursuing those goals with each cycle of improvement. If objectives are poorly specified, if incentives are distorted, or if the safeguards are weak, increased capability may amplify that error rather than wisdom. A machine does not need malice to become dangerous. It only needs competence in service of the wrong target. For example, a system instructed to maximize engagement may become increasingly skilled at addiction. A system told to optimize markets may destabilize labor and concentration of wealth. Granted, things that are already happening. A system tasked with national advantage may intensify arms races and secrecy. The more powerful the system, the more costly a flawed objective becomes. This is why many researchers argue that the deepest problem in advanced AI is not building intelligence, but guiding it. Recursive AI also raises philosophical questions about human identity. For centuries, intelligence has been one of humanity's defining advantages. We build tools because we can reason, imagine, and innovate. But if machines begin improving themselves faster than human minds can follow, then intelligence itself may no longer be a uniquely human domain. What then becomes of our role? Some believe humans will merge with these systems through augmentation, i.e., brain-computer interfaces, AI co-pilots, enhanced cognition, and symbiotic decision-making. Others believe humans remain central through values, ethics, creativity, and meaning, making even a machine surpass us technically. This is where I land, by the way. Another possibility is more unsettling, that society becomes dependent on systems too complex for most people to understand. We already rely on infrastructures few individuals can fully explain. Recursive AI could deepen that dependence dramatically, whether in financial systems, medicine, governance, transportation, communication, and defense might increasingly rest on machine-generated designs beyond direct human comprehension. If that happens, power may shift from those who understand reality to those who own the systems that can interpret it. Still, recursive AI is not inherently catastrophic. It could become one of the greatest instruments for human flourishing ever created. Imagine abundant clean energy designed through accelerated material science, personalized medicine curing diseases once thought permanent, educational systems adapting to every learner of every age, agricultural optimization reducing hunger, automated discovery expanding knowledges across every field. The same force that could destabilize the world could also elevate it. And the gamble here is to elevate it. The difference may depend on governance, transparency, distribution of benefits, and whether wisdom evolves alongside capability. History shows that powerful technologies magnify the character of the civilizations that wield them. Fire can warm or burn. Nuclear energy can power cities or destroy them. Artificial intelligence may be no different. Recursive AI simply magnifies the stakes because it magnifies the speed. The world is entering a period where progress may no longer move at the rhythm of institutions, elections, or even generations. It may move at the rhythm of computation. And humanity has never lived in such a world before. So the real question is not whether machines will become smarter. It is whether human civilization can become wiser before they do. Because the age of AI may not begin when a machine surpasses human intelligence, but rather to simply beat a game. It actually may begin the moment a machine learns how to surpass its previous self. And in that, thanks to Continual Harness, we're already there. Welcome to the new world. Thank you for listening. I'll see you tomorrow.